Yep, comes on everyone. So last thing we were doing relative motion. We'll be starting off with graphs. Now, so what are graphs exactly useful for? Now, if you actually talk about the general purpose of the graphs are useful to to see a large amount of data, right? You can find patterns and you can find everything. When you have a large amount of data, right, you can put them at one place. For example, think of like this. If I'm plotting the graph of, let's say, world population versus the year, right? And let's say you start from somewhere 1800. So 1800, let's say the population is like this. The population is increasing but pretty slow. And then there is a dip. There's again a dip. And if you see this thing, just this graph, you can notice a lot of things. Definitely something happened here. Definitely something happened here. Maybe a World War One and World War Two. Maybe there is a pandemic. Maybe there is some kind of thing, and a lot of people died. And then if you see, then there is a rapid growth. Population went up, and then you see population is becoming stagnant. So maybe because of this, all this lifespan increase because of the new medicines and everything, people are living longer. The birth rate is going up. So multiple things. If you see, right, this might not give you exactly what is happening, but it tells you about something is going wrong or something changed. So graphs are especially useful, to see a lot of data. Technically, that is the main purpose of them. Now, in the same way, in science, when we use graphs, it also shows us, some kind of pattern, something changed, something happened, or something. Now, in kinematics, technically, we study between position, velocity, time. So we want to study all these, relation between them. So let's see in kinematics, what does the graph give? So technically, in a graph, we have primarily two quantities. One is the slope. The second thing is the area under the curve. So in every graph, the slope is dy by dx. We will see what it means. The second quantity that you can study is the area under the graph, which is integral by df. Now, depending on which properties you're taking, the slope and area can have different meanings. So let's see the first standard graph. Now in graphs, right, we have different types. First thing is the standard graphs, which we'll do today. Then we have some non-standard graphs, and then we have to draw graphs of physical situations. I'll give you a situation and you have to put a graph for that. So the first thing is your position time graph. This is one of the, I would say, an important one. Velocity time graph, and these are pretty important because in a position time graph, you can get a lot of information. So listen carefully. So an xt graph, x is the position or x coordinate. So if someone gives you a graph like this, like I said, there are two quantities here, the slope and the area. So in an xt graph, the slope is given by dx by dt. So y का place में x is there and x का place में t is there. Now what is dx by dt? Velocity. That means in an xt graph, the slope gives you velocity. The area is integral position into time. Now there is no meaning for this. So in an xt graph, the area has no meaning, but slope has a meaning. So in xt graph, primarily the slope is the main thing that we study. Example, see how we can interpret this data. if someone gives you a graph like this. Now, seeing this graph, what is saying? This graph is saying the body starts from origin, with speed. Now, what is the speed in this graph? The slope of this tangent. You can clearly see tan theta is 10 by 5. This is your velocity, the slope. So the particle is going with 2 meters per second for 5 seconds. And then slope became 0. It became a flat line. And then stops at x is equal to 10 meters. Meaning this is the situation. The block is starting from x is equal to 0. Initially, it is moving with 2 meters per second. It travels, and then finally it stops at x is equal to 10. It comes to rest. That is the situation. That is the meaning of this graph. Are you getting this? So now understand, this is not the path, okay? This is not the path. This is a graph. The interpretation of this graph is that a particle starts from origin with 2 meters per second, travels for 5 seconds, and stops at x is equal to 10. After x is equal to 10, the x coordinate is not changing, so the particle is at rest. So seeing a graph, you can tell what happened, what is the physical situation, what is happening with the body. Let me give you one more example. What can you tell about this graph? Looking at this graph, what can you tell? Take 30 seconds, then I'll tell you. Then you can see whether you got it right or not. So looking at this graph, what is it telling you about the block? See, body starts from x is equal to 10, then goes backward, because if you look at the slope, with 1 meter per second. Why 1 meter per second? Slope is an angle with the positive x-axis. It is not tan 45, it's tan 135. So be careful. The -1 indicates the body is not going front, it is going back. That's the reason x coordinate is decreasing. And then it comes to rest for some time. That's the reason the line became flat. Stops for some time. Data is not given. We can find that also if you want, but okay. And then again it moves. Again, minus √3 meters per second backward. Again, the slope is tan 120 this time. You have to be careful. Don't take 60. Slope is measured with the positive x-axis. And then finally stops at origin. Finally, it became x is equal to 0. So if you try to draw the physical system of this, This is what had happened. It started here at x is equal to 10 meter, at t is equal to 0. It traveled till some place here, x is equal to 5. It is at rest for some time. Then again it moved with root 3 backward. And then finally reached x is equal to 0. This is what happened with the graph. Is this making sense, everyone? So this is not the path of the particle. Be careful with that. Most people think, body is going like this, down, right, down. But body is simply going in a straight line. Body is not going up and down. Meaning, listen to this thing. Can you tell me how will this person ka graph look like? Let's say we have a person here at x is equal to 0. He goes forward to x is equal to 1. Then he jumps backward to x is equal to 0. Then he jumps backward to x is equal to -1. Then again he jumps forward 0, 1, 0, -1, 0, 1 like this. Can you tell me how will this graph look like? The person is going front, back, back, then again front, front, back, back. How will this graph look like? So if you see, this person literally is going front, back, back, and front, and continuously is doing this. If you try to draw the graph of such a person, you will observe the person is going front, then let's say initially is at origin, then he goes front. The graph looks like this, +1, then 0, then -1, then 0, then +1, then 0, then -1, like this. Are you getting the graph, how it is? This does not mean the man is going up and down, up and down, up and down like this, na? This is the graph. This is not the path. Is that making sense, everyone? The person is simply going front and back only, but look at the graph. It goes up, then down, then up, and then down. This is not how the person is walking here. This is a graph. Any doubts on this thing? Please ask me. If I ask you one more, can you tell me about these two? What can you tell about this? There are two different particles, green and the red one. This is particle 1. That is a graph for particle 1, and the green is up for particle 2. Now, what can you tell about this? We have two particles. One is starting from 2 and one is starting from 3. The green one is traveling with √3 meters per second, and the red one is traveling with 1 by √3 meter per second. And finally, the both of them meet at time t0. Isn't the meaning of that? See, both of them has same x coordinate at t0. Means what? Both of them are at the same position, isn't it? Is that making sense? So particle 1 starts from x is equal to 3 with 1 by √3 meters per second. Particle 2 starts from x is equal to 2 with √3 meters per second, and they meet at t0. There, you can interpret graphs like this also. You can have two graphs on the same thing, and then you can talk something about it. Is this clear, everyone? So this is what I mean. You can see a graph and you can interpret data from that. So let's see. Let me give a question. You guys figure it out. Any doubts on this? Please ask me. Great. It is getting closer and closer, but it is never touching. This is the graph. So what is happening to velocity and acceleration? So exam, if this question comes in the exam, options will be like this. Velocity is positive and increasing. Velocity is negative and increasing. Velocity is increasing. Velocity is positive. Acceleration is negative. Acceleration is positive and decreasing. So they can ask anything like that. They'll make 4 options out of those. What happens to velocity and acceleration? Think, give it a try. Take a minute or two, then I'll show you. Then I'll give you one more like this. So you're giving an xt graph. The only thing you know is slope is velocity. Plus, that is the only thing you know. So from there, we can even talk about acceleration also. You can't tell how much, but you can at least talk about whether it is increasing, decreasing, positive, negative. This much you can discuss. Give it a try. Let's see. In this graph, if you notice the slope, I'll do one thing. Let me draw it more steep. If you look at initially here, look at this thing. This is a tangent, and if you see, it is making an obtuse angle. This is also tangent making an obtuse angle. This is also tangent obtuse angle. This is also tangent obtuse angle. This is also a tangent obtuse angle. The slope is always negative. The slope was never positive, and eventually you're trying to get to 0. Now, just for our convenience, what we will do, I'll give you some numbers. Let's say here slope is -10 because it's pretty steep, and let's say here the slope is -5. Here the slope is -3. Here it is -2. Here it is -1. Here it is -0.5. Here it is -0.25. You can see it's just going down. And this is nothing but velocity. Slope is velocity here. Again, I just took some random numbers, okay? Now from this, you can clearly interpret, first of all, the slope is always negative. If you talk about velocity, slope is negative and decreasing in magnitude. We're talking about magnitude, okay? Meaning, if you try to interpret this situation, this is what is happening. The body is starting from x is equal to 3x naught, t is equal to 0, and this is trying to go towards x is equal to x naught, and this is what is happening. Initially, it started with some 10. Then when it reached here, the speed became 5. Then it reached here, the speed became, let's say, 3. When it reached here, the speed is 2. Then it was 1. And then as you keep getting closer and closer, the speed is becoming 0.01. It's becoming quite small. As you get closer and closer, the speed is becoming even small, 0.00001. Slope is almost becoming 0. So what is happening here? You're always going towards x naught, but you'll never reach x naught. Is that making sense? The closer you get to x naught, the line is becoming flat. When it becomes flat, means it literally stop. It is getting closer and closer to x naught, but it will never go to x naught. Now you tell me, if the velocity is forward and decreasing, how is the acceleration? Isn't acceleration backward? Isn't it? So we can clearly see here slope is decreasing. So here velocity is backward and decreasing. Therefore, you can clearly see acceleration should be forward. And that is also decreasing. Acceleration is this way and decreasing. Why? Again, what is acceleration? Change in velocity. Look at this thing. Initially, the velocity changed from here to here, 5 units in this much time, 5 to 3 in this much time, 3 to 2 in this much time, 2 to 1 in this much time, 1 to point with this much time. It is becoming more and more difficult for acceleration to decrease the speed, isn't it? Speed is not decreasing as fast as before. Initially, the speed was decreasing rapidly, 10, 5, 3, and then look at the end. The speed is changing very small amounts even for a long time. Doesn't that mean acceleration is decreasing? Acceleration is simply change in velocity by time. Is that making sense? Look at here. For this distance, the change in speed is 10 minus 5. For this much distance, the speed is 1 minus 0.5. So acceleration is also decreasing. There, that much we can interpret. And the particle gets closer to x naught, but will never reach x naught. As it gets closer and closer, it becomes more slow and slow. That is what you can tell about this graph. Have a look at this. Please ask me if you're confused. There, this much you can tell about acceleration, whether it is increasing, decreasing, direction, you can say this much. So velocity is minus I cap, acceleration is plus I cap, and both are decreasing in magnitude. And the closer you get to x naught, the slower you go. So you'll never reach. Clear? Let's see one more like this. Again, what can you say about velocity and acceleration? Idea is the same. Hmm. Let's see. Same idea there. Look at the slope. Initially, it is acute angle, steep. Then it is less steep, but it is still positive, 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 positive. It is becoming zero. Again, if you give some numbers, it will be plus 10, 5, 3, 1, let's say zero point 0.5, and let's say 0.01. So basically, this will be your velocities. Again, I'm just giving random numbers just to, it will be more easy to observe, nothing much. So we can clearly see velocity is positive and decreasing. Means the body is going front. It is going from -5 to plus 10. Velocity is positive and decreasing. And obviously, velocity is positive and decreasing, meaning acceleration is negative, and that is also decreasing. Because if you see, velocity is not decreasing as fast as before. Clear with this? How will acceleration positive and increasing look like? How will a positive acceleration and increasing will look like? This would look something like this. It's going faster and faster, no? Look at this thing, the slope. Here it is 0, 1, 2, 10, 100, 1,000. You can see the number is just rapidly blowing off. Means the velocity is increasing at a much faster rate. As you go more and more, it goes much faster and faster. The slope is becoming steep. So this would be a case where acceleration is positive and increasing. Clear with this? Any doubts on this? Let's see another variation of this. There's a graph like this. So the question is, how many times velocity becomes zero? Again, when I say velocity, instantaneous velocity. Average velocity becomes zero. Two different questions. Try. Take a minute. Let's see. Now, first thing, what is velocity? Velocity is simply slope. So how many times it is becoming 0? So 1, 2, 3, 4, 5, 6. Slope is 0 6 times. Basically maximum minimum points. Now what is average velocity? Average velocity is x final minus x initial by time. So here I'm indirectly asking you how many times you come back to the same position. So here you're starting at x naught. So ask yourself, see, people think like this thing, I'm not asking you how many times you cross the origin. You're crossing origin 2 times. That has nothing to do with the question. Displacement should be 0. Displacement is simply initial and final coordinate must be same. So you came to x naught how many times? You came once here, second time, third time, meaning you came back to the same coordinate, fourth time. So 4 times, right? 4 times x final is equal to x initial. So the average velocity becomes 0 4 times. Is this making sense, everyone? If I ask you how many times you cross origin 2 times. But that has nothing to do with the question. But most people think average velocity matlab x coordinate is 0. No. Average velocity matlab final and initial coordinate must be 0. Displacement is 0. Is this making sense? Adi, clear with this? Adi, is this clear? Yeah. Please make sure to stay back after the class today. I need to talk to you. And then, clear with this? Let's see one more like this. You just tell me the answer for this thing. Now, how many times velocity is 0? How many times average velocity is 0? So 1, 2, 3, 4, 5, 6. 6 times average velocity is 0. What about this thing? Maximum minimum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times v bar is 0. Easy? That's it. So this thing, something like this, you can do it like this. It's an easy one. You should know just the slopes and the times. Any doubts on this question? Please ask. These are the kind of questions you get in mains and bits. And how is this guy going actually? If you look at the path, you're starting at some point here, x naught. Then you went front. Then you came back. Then you stopped. Then you came front again. Then you went back. Then you went little front. Then little back, little front. Then you went little more. Then you went little back, and then you went. All this are happening on the same line. You're getting it? This is simply going front, back, like this on the same line. For you to understand, I just draw it to the side. Is this making sense? Next one. So we have a point A here. We have a point B here. So we have a tangent here at this point, making 60 degrees. We have a tangent here at this point, making 60 degrees. This is point B. So particle is going from A to B. This is your 10 seconds. This is 20 seconds you reach B. This value here is plus 10 meters. This value here is minus 10 meters. That is the information you have on the graph. So particle moves from A to B in 20 seconds. So find the average velocity and the average acceleration. Let's get this. If slope is 0, slope is 0, then automatically velocity is going to velocity be 0 when the line touches x-axis in the case. What are you talking about? So you're saying dx by dt, x is 0, the dx is 0. Is that what you're trying to say?
Yes.
So you mean to say x and dx are same?
No, sir, because a differentiation of a constant should be 0. So
Where is it constant? Suppose if I say x is equal to t square plus 1, if I ask you find
Sir, I got it.
dx by dt at t is equal to 1, what do you do?
Sir, I got it.
You differentiate and then substitute. You don't substitute and differentiate. So let's get this. Be careful, x's and dx are completely two different quantities. They don't mean the same thing.
Yes.
Yeah, let's try this, everyone. Okay, we have one answer, which looks wrong. Definitely looks wrong. Vihan. What are you guys trying to find exactly? Average acceleration is what? V final minus V initial by time. Hmm. Right, generally. Looks like you got it right. Let's see. First thing, average velocity is simply x final minus x initial by time. What is x final? Minus 10. What is x initial? Plus 10. What is time? 20 seconds. What is the answer? Minus 1 meter per second. Bus. Go back to the definition. Average velocity is simply change in position by time. Average acceleration, that is v final minus v initial by time. Now, what is v initial? Slope. Where? Slope at a. What is the slope at a? Tan 120. The angle should be taken with the positive x-axis, which is minus root 3. V final, which is slope at b. I did a mistake. Wait, I got it. Why you got it wrong answers? I wrote this wrong. So Janil, I think you also took it wrong. This is 60 degrees, right? My mistake. That thing is obtuse. Huh, I think then you guys are right. That is my mistake. Then it would have been 2 root 3 by 20. Root 3 by 10 you would have got, right? Yeah. Whoever got root 3 by 10, you were right for that data. My mistake. That is supposed to be an obtuse angle. I gave it wrong. So slope at B also would be tan 120, which is minus root 3. You get a 0. Yeah, that was a mistake. My mistake. But still, if you have taken that, then the answer would have been root 3 minus of minus root 3. So by 10 to root 3 by 20, root 3 by 10. Yeah. Easy? Clear? Next one. Next one. Any doubts? Please ask me. Ojas, clear? Niharika? Daksha? Arya? Abhinav? Clear? Daksh? Got this? Adi? Ahana? Clear? Adi? Clear? Stuck, I guess. The problem with the net. Next one. So this is A, this is B, this is C, this is D, and this is Z. In which region the particle is speeding up? Options will be A, B, B, C, C, D, D. ऐसा 4 options होगा. In which section particle is speeding up? I hope you remember speeding up meaning speed should increase. Yeah. Try. I'll give you a minute. Hmm. Hello, Adi, are you there? Let's say. So if you look at the slope here, slope is positive and decreasing. Pause at 0. Negative, more steep, less steep, again 0, again this thing, again 0. If I again put some numbers for convenience, this is +5, +3, 0, -3, -5, -3, 0, +3, +5. Can you see? Just put some any random numbers, doesn't matter. So the question is speed should decrease, isn't it? So A to B speed is decreasing. I don't care about direction. I just want the magnitude, right? Since it is speed. And O to B to C, even though it is going backward, but it is increasing. 0, -3, -5 magnitude is increasing. Similarly, C to D is also decreasing, and D to E is also increasing. So there are two answers, P, C, and D. Is that clear, everyone? So there is a multiple choice question. There are two answers. You just need to see where is the magnitude of slope is increasing. I don't care about the direction or the sign. We are just interested in the magnitude. Clear with this thing, Puroja? Got this? Nikhil? Ansh? Arnav? Clear, na? Can I go ahead? Vignajit? Ojas? Adi? Clear? Yeah. Next thing. Velocity time graph. Now, this is another important graph because this is one graph where both the slope and area both have a meaning. So in a VT graph, the slope is given by dv by dt. That's nothing but acceleration. So in an acceleration time graph, slope is acceleration. The area is integral v dt, which is nothing but displacement. Which is x final minus x initial. Now here you have to be careful about one thing. The area rate can be positive or negative. So if you have a VT graph like this, the area below the time axis is a negative area. Because see, below the time axis, the velocity is negative, time is always positive, so the area is negative. The above time axis, the velocity is positive, right? And the time is also positive, it's a positive area. So generally, this is the convention. So any area below the time axis, we take it as area below time axis is negative. Area above time axis, we take it as positive. So if someone asks you to find displacement, meaning the meaning of this thing is, see, when you say positive area, let's say if I got positive area 100, means you went 100 units forward. If I say negative area is -50, means you went 50 units backward. That's the meaning of this. So displacement is simply the positive area minus the negative area. So just find the area magnitudes and subtract them. If you want distance, it doesn't matter whether you go front or back, so you always add it up. So just add them up. Have a look at this. So for distances, you just add all the areas. For displacements, you add them with the sign. Area above is positive and area below is negative.
Sir, could you just explain this again? I lost connection.
Which part?
So this velocity time graph.
Full thing.
Yeah.
Why were you disconnected? Record. See. So in this thing, slope means what? Acceleration, dv by dt. Area is what? Velocity into time. That gives you displacement. So in a VT graph, both the slope and the area have a meaning, right? But when you say area here, if the area is above the x-axis, the time axis, we take it as positive. Because v is positive, time is also positive, means it is going forward. Area below the time axis, we take it as negative because velocity is negative, time is positive, means it is going backward. So if you want displacement, you should take the positive area and the negative area, you have to subtract them. But if you
Okay,
want
so
distance traveled, then you just have to add both the areas because you go front or back, it won't matter. Na?
Okay, sir. Thank you.
Meaning example सोचो अगर ये 100 आया और ये 50 आया मतलब क्या you went 100 forward and 50 backward तो displacement होगा 100 minus 50 but distance होगा 100 plus 50. Make sense? Yeah. Have a look at this, everyone. Let's see a problem based on this. Turn in the page. This is 4 seconds. This is not up to scale actually. This is 8 seconds. This is 12 seconds. This is 14. This is 16 and this is 18 seconds. This height here is 10 meters per second. This height here is minus 5 meter per second. Find distance and displacement in 18 seconds. And using this graph, can you plot the acceleration versus time graph? Let's get this. Graphs are easy actually. If you see, it is only about like finding slopes and areas, unlike relative velocity where we did more dangerous ones. In that sense, graphs are not really that tough. Give it a try. So it is mostly about finding the area under this. So let's see how to do that. You can actually use trapezium K area, or you can just simply find the area for each piece. So if I try to find the area of this guy, that is half base into height, that is half, that is 20. And then this area, that would be a rectangle, which is 4 into 10, 40. This also would be 20. That's the positive area. This would be half into, so this is 5. This would be 10. And this also would be 5. So if you just want distance, displacement, you take the total positive area minus negative area. The positive area would be 80 minus 20, that is 60. If you want distance, it is 80 plus 20, that is 100. Easy. Now how to plot the AT graph for this? So looking at a VT graph, can you plot an acceleration time graph? Try. I'll give you 30, 40 seconds, then I'll show you. Remember, in a VT graph, the slope gives you the acceleration. Look at this thing here. So for this line here, what is the slope? Tan theta, opposite side, which is 10 by 4. So slope is 2.5, isn't it? Then this horizontal line, the slope is 0. So indirectly, I'm telling you to draw the slopes. And this guy, slope is minus 2.5. This guy ka slope is also minus 2.5. This is 0 and this is 2.5. So this is how the graph would look like. If you plot an acceleration versus time graph, so initially the slope would be plus 2.5 for 4 seconds. Then it drops to 0 for another 4 seconds. Then it drops to minus 2.5 for another 4 till 14 seconds. Then again drops to 0 for 2 seconds and then 2.5. This would be 18. So this would be 2.5 and this would be minus 2.5. Make sense? That's how the graph looks. It's a pretty straight line. It's all constant acceleration, so the graph looks fine. So I can ask you one graph and I can give you one graph and ask you another graph. Let's see one more. Next thing. Let's say we have a VT graph like this. Let's say this is 30. This is 45. This is 60. Let's say this is 30. This is 30. So approximately, can you draw 80 graph of this? Wait, I'll do one thing. Wait, I'll change something here. This is 60 degrees, and this line which you have, this equation, right, is something like A is equal to some t square minus some number. T square minus something, let's say 10. So that green line acceleration is t square minus 100. Not A, sorry, V. So meaning there are straight lines and there's a curve also now. Now plot 80 graph. We don't know the time, so approximately how will it look like? Try, I'll give you a minute. Just give it a try and get some water now. Done. See. So if I try to plot an 80 graph, so initially the slope here is constant, that is 1 by root 3. Slope is 0, slope is 1, slope is 0. Here slope is tan 120. Yeah? You should always take with the positive x-axis. So minus root 3. So this guy is also minus root 3. This guy is plus 30. So 1 by root 3. This is interesting. Huh? So if you differentiate this, we get acceleration is dv by dt, which is actually 2t. It's a line passing through origin. We will talk about that. This slope is also minus root 3. So if you try to plot the graph, so initially your graph starts at 1 by root 3 for some time, then it becomes 0, then it suddenly bumps up to 1 for some more time, and then suddenly again then comes to 0, then the value drops to minus root 3. This goes on for pretty long, and then suddenly value bumps off to again 1 by root 3. And here the graph, right, if you see, it's a line passing through origin. So that green thing, I'll just draw with a line. So it'll be like this, a straight line. Where this line ka slope na tan theta is equal to 2. Because see, this thing is looking like y is equal to mx. This a is equal to 2t. Looks like y is equal to mx. It's a line passing through the origin, meaning I didn't draw it properly, but if I extend the line, it will pass through this line here. So it will be something like this. And then the graph will suddenly become again minus root 3 here. Like this. So yeah, that's how you can play around it. Just you're playing with the slopes. So I can even introduce curves in middle. Then you have to differentiate and get the acceleration. You can play like this. So in the graph, suddenly there is a line like this, an inclined line, and then drops again. Is this clear, everyone? So if I give you one graph, I can ask you another graph. So this is how you do those things. Let's see one more. Turning the page. We have a VT graph. This is 10 meter per second. This is 10 seconds. This is 20 seconds. Find distance traveled from t is equal to 12 to t is equal to 18 seconds. And find the time when the displacement becomes 0. Let's get this. T and 40 near, that's not the answer. Let's see. So indirectly what I'm asking here, from 18, you want from 12 to 18, right? So 12 is somewhere here. 18 is somewhere here. I want the area of this trapezium in the middle, isn't it? Now, if you look at that triangle there, you can clearly see this angle is 45 degrees. How? This length is 10. The base is also 10 to 20, see 10. So this angle is 45 degrees. If that is 45 degrees, this is 18, this is 20, so this is 2, so this height is also 2. This is 12, so this difference is 8, so this height is also 8. So for this trapezium, so you created a trapezium like this with the sides 8, 2, and 6. Don't you know the area of the trapezium? Half sum of the opposite, the parallel sides, 8 plus 2 into 6. 30 meters, that's your distance. Easy? What about the second question? Find the time when the displacement is 0. How do we do that? First part is right, second part is gone. Try. I'll give you a minute. Find the time when the displacement is 0. Let's see. Right answer. So when I said displacement is 0, indirectly you're asking the positive area and the negative area should be equal. So let's say at time t, so this is the negative area, so that the black shaded area there, and this green area should be equal. Isn't that the meaning of it? That's the meaning of displacement is 0. So this area is 100, this area is 50. Now we know this angle is 45, so this angle is also 45. So this width would be t minus 20. So opposite side is also t minus 20. So this area would be half into base into height. Therefore, the total area is 150 minus half into t minus 20 ka square, and you want it to be 0 because the displacement is 0. So that would give you t minus 20 is equal to root 300. T is equal to 20 plus 10 root 3. So at that time, the total area becomes 0. Is this making sense, everyone? So be careful. That is the meaning of that. Displacement is 0, meaning whatever you travel forward, you have to travel the same thing backward. So positive area and negative area should be equal. Like I said, if you see the whole thing, we're just finding areas and slopes. We aren't doing anything big here. Like relative motion, maybe did more dangerous ones. So in that sense, graphs are easy, but then again, you should practice some models. Just because it is easy doesn't mean, in the exam you'll be able to do it. So keep that in mind. Even if something is easy, if you don't practice at least a decent amount of problems, exam you won't get speed. Maybe till now, right? Calculus and vectors, you saw that and you thought that was physics. So if you're still living in that illusion, right? Vectors and calculus में marks आ गया, तो मैं physics अच्छे से हो रहा है, it is easy. Yeah, welcome to life. You'll get slaughtered. You saw in relative motion how the problems were. Cat and dog, particles chasing each other. Things will even go up, meaning this is still nothing. We are still rising. Remember I told you, I think I gave in the beginning, right? The difficulty versus time or the difficulty versus chapters. So it was like something of this sort. This is rotational mechanics. I think we are somewhere here. So there, meaning not bad, meaning still this is not anything less than the amount of time we did. We're still going to reach there. That is the thing. So we are somewhere still here. I think rotation we should reach somewhere by December or Jan. Abhinav wants to find the slope of the graph. Slope of the graph is proportional to the amount of time we cry because the paper is tough. Next thing. So that's about a VT graph. And the next one is AT graph. The remaining graphs are not really that tough. The main ones are XT and VT only. So in an acceleration time graph, again, same thing. Here also you have a positive area and a negative area. So here slope is dA by dt. There is a name for this. They call it jerk, but we don't need it. So it is actually kind of useless for us. So in AT graph, the most important thing is the area. So area is acceleration into time, which is change in velocity. Be careful, huh? This was asked in the mains of bits, I guess. The AT graph gives you what? Velocity, change in velocity, something like this. People wrote velocity and came. It gives you change in velocity. Same convention, area above time axis positive, area below is negative. Clear? The next one, acceleration position graph. So you have to be careful whether it is AX or AT. That one symbol will change the whole thing. So here the slope dA by dx, it means nothing. Interestingly, area means something here. Integral A dx. You know what is this? V square minus U square by 2. The third equation in the kinematics. V square minus U square is equal to 2as. Have a look at this. So this thing has a meaning. So a t graph gives you V minus U. A x graph gives you V square minus U square by 2. Both are completely two different things. Clear? Let's see a question on these two. Pi meter per second square, 10 meter per second square. This is 5. This is 10. This is 15, and this is 25. Same graph. Suddenly, this is not t anymore. This is x. Meaning this is 5 meter, 10 meter, 15 meter. This was 5 second, 10 second, 15 second. So in both the graphs, the initial velocity is minus 10 meter per second. Find final velocity. So this one alphabet at the denominator, right? T or X will change the whole answer. So I'm doing both together so that you have an idea. Because I have seen, they give AX graph, people do AT graph answer and they solve. And unfortunately, the answer will be there. So AT graph gives you V minus U. AX graph gives you V square minus U square beta. That's the only difference. Other than that, if you should know for every graph, what does area mean, what does slope mean? Other than that, there's nothing else in this thing technically. You have to think about slopes and stuff, but yeah, you did right. You just have to find the area under that shape. Okay, did you find the area under this thing? Let's find the area under this thing. So this small thing, this area is half into 5 into 5, 25 by 2. This would be 5 into 5, 25. I'll just change the color. This guy would be another 5 into 5, 25. This guy would be another 25 by 2. This whole thing, you can take one triangle, which is half into 10 into 10, 50. So we can clearly see here, so total area would be 25 by 2, 25 by 2, 25, 75, 125, right? Did I get the area right? So in the first case, this is nothing but V minus U. So 125 V and U is given as minus 10. So V is equal to 115 meters per second. In the second case, the area is still the same, 125, but this time this is V square minus U square by 2. This is 250, this is V square, and that is minus 10 square. So V square would be, V would be root 350. You can see how much the answer changed. So be careful. Always be careful which graph are you talking about, AT graph or AX graph. The whole thing can mess up the answer. Clear? The next one. Yeah, be careful with the next thing is a velocity position graph. You can see like different combinations ka thing. So in every graph, the main thing is that what is slope, what is area. The velocity position graph is another, I won't say non-standard, but it's a little different. If you take here, the slope is dv by dx. It means nothing. Area is integral v dx. That also means nothing. But if you remember, the acceleration is v dv by dx. So velocity at a point into slope means something. So only slope is useless, but slope into velocity gives you acceleration. So in this really, there's not much they can ask, except they'll give you the data. Example, it would look something like this. So let's say there's a point P here. Now let's say if I draw a tangent here, let's say this is 60 degrees. This is 10 meters per second. So acceleration at point P is velocity at point P into slope at point P. So velocity at P is 10 and the slope would be tan 120. Always be careful if you take the other side, minus 10 root 3 meters per second square. Again, so be careful. VT graph alag hai, VX graph alag hai. So technically, these are the 5 main graphs remaining: XT graph, VT graph, AT, AX, and VX. AV graph has no meaning. AV graph ka area, slope, it has no meaning. AV graph. These are, if you can say, standard graphs. Other than this, we also have non-standard graphs, like those we will do in the next class. For example, let's say V square and X cube. No, this is completely something weird. Or let's say V square T graph, or 1 by X versus V graph, meaning you can take any quantities and any graphs. Now, these are all non-standard graphs. So we will see how to approach those kind of graphs. If you give me something weird quantities like square or 1 by X and all, so that is one. And the second thing, right, is situations. Like, you have a situation and you have to plot a graph for that. So let me ask you one like that as a homework. You give it a try. We will discuss. So this we have done before as a problem. So particle is projected with speed u. It goes up, comes back, hits the ground with a speed u by 2. Again goes up, comes back, hits the ground, speed becomes u by 4. We have done this from, remember? So it just keeps on bouncing, and eventually stop. So a particle is projected with speed u. Right? its speed becomes half after hitting the ground. So the speed keeps on becoming half. I think this, where did we do this? This question 20. Remember this? There I asked you total distance, total time, and average speed. This was the question 20. Same thing. So this graph, I wanted to plot velocity time graph, displacement time graph. This would be an advanced paragraph question or a matrix matching or anything. Distance time graph. So you have a situation, you have to put a graph for that. Distance time graph is interesting. And velocity displacement graph. So these 4 graphs, give it a try as a homework. So next class, when we catch up, we will do this. Then we will see some physical situations, and then we will see non-standard graphs. So they're not much. I think we have done almost 85 problems. Huh? I think we will touch around 88, 90. So do make sure to resolve the entire notes again once more. So next class, when we catch up, we're going to wrap up the chapter. And then after that, we'll start off with units and dimensions. Units and dimensions done, right? Yeah, so it's a small chapter, maybe 2 to 3 classes. We'll wrap up that, and then we'll go for Newton laws of motion.